Diophantine equations. Example 11.1. A farmer spent $100 to buy 100 animals of 3 different kinds. Cows cost $5 each, pigs $2 each, and sheep 50 cents, which is half a dollar each. Assuming he purchased at least one of each animal, how many of each did he buy? So I'm going to begin by assigning variables to the number of cows and the number of sheep and the number of pigs. So let's let x, whoops, equal the number of cows y can equal the number of pigs, and z can equal the number of sheep. Now, the two equations and the 3 unknowns that I'm going to have to create, one is that we know he bought 100 animals, so x plus y plus z has to equal 100. The next equation will come from the cost, because we know how much he spent. All right, so since each cow costs $5, that means he spent 5x on cows, and each pig cost $2, so we know he spent $2 on pigs, and each sheep was 50 cents. I'm going to write that as half of a dollar. All right, and that's equal to 100. Now, I don't like that fraction, so I am going to change my second equation by multiplying through by a 2. That's going to clear my fraction. So this is now going to become 10x plus 4y plus z equal to 200. And what I'm going to now do is I'm going to take this new equation, 10x plus 4y plus z equal to 200, and I'm going to subtract out the first equation, x plus y plus z equal to 100. And I am going to subtract every single term. And the reason I want to do this is I'm going to be knocking out these z's, because z minus z is going to be 0z. So that's the idea. When I do this, I end up with 9x plus 3y equal to 100. Now, I'm going to take this new equation, all right, I'm down to 2 variables, and I'm going to solve for one of the variables. And you don't really, it doesn't really matter which one you use, but my suggestion would be to take the term with the highest coefficient over to the other side. In other words, I'm going to subtract 9x from both sides, because not instead of 3y from both sides, because the coefficient on x is bigger than the coefficient on y. And what this will do is this will shorten the next step. You won't have to do as many tries if you do that. So I'm going to begin by subtracting that 9x. So I have 3y equal to 100 minus 9x, and then dividing both sides by 3. So I've now solved for y. Y is equal to 100 minus 9x, all divided by 3. And at this point, we're ready to go to our feasibility table. And what you want to do is you're going to start with x's, because x is what you're going to be plugging in first. All right, so you're going to make a feasibility table with x, and then once you've figured out what x is, you're going to get y. If y gives you a feasible answer, in other words, the solutions to Diophantine equations have to be positive integers. So as long as y is not a fraction, or as long as y is not a negative number, all right, then it's acceptable. We can go ahead and find z. But and we'll find z because we know the three variables have to add up to 100. All right, so that's how we're going to get to z. So you start doing this, and I'm going to start by figuring out what's the smallest thing, or the largest thing, excuse me, what's the largest number that x can be, so that y still remains positive. So in other words, if I let x equal 20, y is going to be a negative number because 100 minus 9 times 20 is going to be a negative number. So we have to find the largest value for x that we can, so that y still remains positive. And that number is going to be 11. And if you want to know a shortcut for finding that out, all you need to do is divide 100 by 9 and round down. No matter whether, no matter what number you just get, just chop off the decimal part. All right, you can use your calculator to do that. And so now we know we're going to check 11, 10, 9, 8, and so forth until we see if we can find a solution. So, feel free to use your calculators. If I plug 11 into this equation, I get 100 minus 99, that's a 1. 1 over 3 is 1/3. And that's not a good solution because it's not an integer. So now we're going to move down to 10 and see what happens when we put in a 10. 100 minus 9 times 10 is 10, because that's 100 minus 90. So that's 10/3. That's still no good. Okay, now we're going to plug in a 9. When we plug in a 9, we get 19/3. Now we're going to plug in an 8. When we plug in an 8, we get 28/3. Still no good. Okay, now I'm going to plug in, let's see, 7, 6, 5, 4, 3, 2, 1. Okay, plugging in a 7, I get 37/3. No good. Plugging in a 6, I get 46/3. No good. Plugging in a 5, I get 55/3. No good. Plugging in a 4, I get 64/3. No good. Plugging in a 3, I get 77/3. Still no good. Plugging in a 2, I get 82/3. That's not good. Oh, and now plugging in a 1, my last shot, I get 91/3, and that is not an integer either. So this Diophantine equation had no solution. There were no solutions to this problem.